Hello. So now I'm going to discuss three questions for the last stream, that is the W stream. After that, I'm going to discuss ME stream questions, mechanical questions. So the question is the expected number of trials for first occurrence of a head in a biased coin is known to be 4. The probability of first occurrence of a head in the second trial is. So this is from engineering mathematics from the topic probability and statistics. Subtopic random variables. The solution is expected means average number of trials for the first occurrence of head. This is event. Average is given 4. Okay. So solution. This is head and tail coin problem. Biased coin. Probability of first occurrence of head in second trial. This is we are going to find. Biased coin. These are the key points. So anyhow, for unbiased coin, head and tail having same probability, that is each is equal half. But for biased coin, it is not mentioned. So probability of getting head taken to be small p and small q is equal probability of getting tail. Let small p is equal to probability of getting head. Okay. In any single try. And q is equal to probability of getting tail. For a biased coin. For a biased coin. Okay. Please remember this. And let capital X, because here expected number of that X, expected means average of a random variable X. What is that random variable X? Denotes number of trials for getting occurrence of it, first time occurrence of it. Let X be a random variable. RV means random variable. Denote the number of trials. NO dot means number for getting first occurrence of a head. In bracket, that is denoted by capital H. Then we have a table capital X versus probability along with event, and then you know that expectation of X, that is average for a discrete random variable. Number of trials here, discrete random variable only. Event capital X is equal to small x. Capital X value is denoted by small x and P of small x. Probability of this value. This is now. So when one try, first try, if you get head, that is event H. What is the probability of getting head in one trial? 1 by, that is we denoted by small p. Denoted by small p. For unbiased coin, it is 1 by 2. If you do not get head in the first toss, first trial or first toss, you have to toss second time. That is number of tries is 2. Now the event is TH. This T is first toss, H is second toss. That is toss means here trial. Now probability is Q into P. Q is the probability of getting tail in the first trial or toss. P is the probability of getting head in the second toss. If you do not get head in the second toss, then you have to toss third time. That is, X denotes 3 trials. Now the event is TTH. Corresponding probability of this X is Q into P. So the game never ends generally. Okay. So on continuously. Now, given expected number of trials, number of trials X, expected E letter. So mathematical notation is E of X is equal to given, that is 4. Okay. So this is X is discrete random variable. 1, 2, 3 are discrete values or not. Okay. So how do you find this expectation? Mean summation of product of X and its probability. Okay. That is summation X is equal to 1 to infinity X into P of X is equal to 4. So giving 1 by 1 value for X, 1 into P of 1, that is small p, plus 2 into P of 2, QP, plus 3 into P of 3, Q into Q square P, plus so on. This value given 4. Now in all this, P is common. Take out 1 plus 2Q plus 3Q square plus so on is equal to 4. Now this is a AGP, arithmetic geometry progression, or some standard binomial series expansion, 1 plus 2x plus 3x square, etc. So this simplifies to P times 1 minus Q whole to the power minus 2 is equal to 4. Since 1 plus 2x plus 3x square plus so on is equal to 1 minus x whole to the power minus 2 if on one condition minus 1 less than x less than 1. Whenever x value lies between minus 1 to 1, this expansion is valid, that is convergent. Now Q, getting tail probability is always lies between 0 to 1 only. So p small q lies between 0 to 1 only. So that's why this formula is applicable for here. Now, what is 1 minus q? Probability of getting head plus probability of getting tail is always equal to 1. So 1 is equal to 1. Probability of getting head, small p is equal to 1 minus q. Similar, small q is equal to 1 minus p. So this is p times p power minus 2 is equal to 4. Since probability of head plus probability of tail, only two outcomes. One, that is small p plus q is equal to 1. Now this is 1 by p is equal to 4. From this, small p is equal to 1 by 4. Okay. So automatically q is equal to probability of getting tail 3 by 4. P plus q is equal to 1. Now the question is probability of first occurrence of head in second trial. Okay. Therefore, probability of first occurrence of a head in the second trial, that is automatically first trial getting tail, is nothing but probability of TH. So probability of TH event outcome is, that is given Q into P. See, this is event TH, probability is QP. Okay. So this is 3 by 16, approximately up to 3 decimal places. They have asked 0.188 up to round off to 3 decimal places. So the answer is 0.188. This is the answer, end of the question. Next, the question is, the closed curve shown in the figure described by r is equal to 1 plus cos theta. This is cardioid diagram. where r is equal to root over x square plus y square, x is equal to r cos theta, y is equal to r sin theta, polar coordinates. The magnitude of the line integral of the vector field f bar is equal to minus yi cap plus xj cap around a closed curve is. This question is from engineering mathematics from the topic vector calculus. The solution is so we know that here the cardioid C is a closed curve. Okay, this is the C curve actually. Okay, C is a closed curve and f bar is 2D. 2D means two-dimensional vector, two coordinates only there. So I can apply Green's theorem. Though they asked line integral. Therefore, line integral of f bar around C, C is a closed curve, is integral over C. This is the symbol closed curve f bar dot dr bar. Okay, where r bar is nothing but xi bar plus yj bar in 2D variables. This is now f bar dot dr bar. How do you get directly without writing dr bar? In f bar ij respectively replaced by dx dy. So this is integral over closed curve minus y dx plus x dy. Okay. So this is line integral notation and this is observation closed curve 2D. Now I am going to apply Green's theorem. Why? Because this is a closed curve. It looks like m into dx plus n into dy. Am I correct or not? So Green's theorem, what is that? Green's theorem is equal to double integral over r dou by dou y of n, that is x. Am I correct or not? Dou n by dou x dou by dou n of dou by dou x of n minus dou by dou y of m. Have you remembered the condition? Dou m by dou by dou n by dou x, all this dx into dy. What exactly will be getting? If this is a constant, not required to integrate double integral without writing the limits. Double integral dx dy represents area of the region bounded by a closed curve C. Okay. Whenever you will be getting some x term, y term, some integrand x plus y or x into y, you have to integrate term by term after finding x limits and y limits. But the equation is given in polar coordinates. Let us check. So this is dou by dou x of x is 1 and dou by dou y of m actually. What is m value? Minus y. Dx coefficient is m, dy coefficient is n. Okay. So what is this actually? Dou by dou y of minus y. So minus into minus plus, x derivative with respect to x is 1, y derivative with respect to y is 1. So simplifies to 2. Take out 2. It can be written as double integral over r dx dy. Okay. You are understanding or not? Following or not? dx dy. Now what exactly this represents? Double integral over r dx dy is called area. Okay. So this is equal to 2 times area of the region R bounded by C. So this is region R, that shaded region. Okay. So this region bounded by a simple closed curve C. That's why apply Green's theorem. Using Green's theorem actually here. Using Green's theorem. Okay. Using Green's theorem. Now, what is the area of the region? This area of the region bounded by curve. Curve equation is expressed in polar coordinates. So area in polar coordinates is half times integral r square theta, where that integral having the limits with respect to theta. So this is equal to 2 times half times integral theta limits over the chordioid C. This is anti-clockwise direction 0 to 2 pi. 0 to 2 pi r square d theta. This is the formula for finding area in polar coordinates. Okay, since in polar coordinates comma the area bounded by the curve r is equal to f of theta, that is equation of the curve in polar coordinates is expressed as r is equal to function of theta between the radial lines. Theta is equal to alpha and theta is equal to beta is half times integral alpha to beta, that is theta limits. Okay, because the curve equation is expressed in terms of theta. R is expressed in terms of theta. Alpha to beta r square d theta. This is the formula. So we know the relation between r and theta, that is given by the curve equation. R is equal to 1 plus cos theta. This is the curve. Okay. So 2 half cancel, 0 to 2 pi 1 plus cos theta whole square. Okay, d theta. So you know that 1 plus cos theta 2 cos square theta by 2, using that relation or directly expanding a plus b whole square. 0 to 2 pi 1 plus a square plus 2ab 2 cos theta plus b square cos square theta d theta. Again this cos square theta. We don't have direct integration. Using trigonometry, 1 minus 1 plus cos 2a. 1 plus cos 2a is 2 cos square a. So that cos square a can be written as 1 plus cos 2a by 2. Now, the total constant 1 plus 1 by 2, 3 by 2. And the cos theta term is 2 cos theta. Cos 2 theta term is cos 2 theta by 2. Between the limits 0 to 2 pi. So, constant integration, constant into theta. Between the limits 0 to 2 pi. Term by term integral. 2 into cos theta integration with respect to theta, sin theta. Between the limits 0 to 2 pi. 1 by 2 into cos 2 theta integration is sin 2 theta by 2. Between the limits 0 to 2 pi. Sin any number into pi 0. Okay, so these two terms vanished for upper and lower limits. This is 0 and this is also 0. Okay, so finally we left with this 3 by 2 into 2 pi minus 0 simplifies to 2 pi. So finally this simplifies to 3 pi. So pi value approximately 3.14. So this is simplifies to approximately 9.42. This is the answer. This is the end of the question. Now the question is, a quadratic function of two variables is given as f of x1 comma x2 is equal to x1 square plus 2x2 square plus 3x1 plus 3x2 plus x1 x2 plus 1. The magnitude of the maximum rate of change of the function at the point 1 comma 1 is round up to nearest integer. This is from engineering mathematics from the topic vector calculus, subtopic that is vector differentiation, gradient related problem. So magnitude means mod. Maximum rate of change means of the function means del f. Point is given. Answer round up to nearest integer. Okay. So solution is, you know that formula, grad f, mod grad f at that point gives the maximum rate of change of the function phi. So the maximum, I mean magnitude, the magnitude of the maximum rate of change of f means function, is at the point at p 1 comma 1 point is del f at the point 1 comma 1 at the point p, and then magnitude means this one. Okay. Now see, f is a three variables, so del f is equal to function of two variables, I cap dou f by dou x1, the two independent variables x1 x2. Given function is a two variables function, two variables, plus j cap dou f by dou x2. So this is equal to I cap partial derivative of f with respect to x1, here 2x1, and here 0, and this is 3, and this is 0. X1 x2 derivative with respect to x1 means x2 constant, so x1 derivative 1 plus 1 derivative 0 plus j cap into with respect to x2 partially means x1 square 0, 3x1 0, 1 0, remaining 2x2 square derivative 4x2 plus 3x2 derivative 3 plus x1 x2 derivative is x1. Okay. So at the point p 1 comma 1, so substitute x1 is equal to 1 and x2 is equal to 1, 2 plus 3 plus 1 into I cap plus 4 plus 3 plus 1 into j cap. So this is 6 I cap plus 8 j cap. Okay. So therefore mod del f at the point p is nothing but modulus means magnitude square root of sum of the squares of the coefficients of ij. 6 square plus 8 square, 64 plus 3600. So this simplifies to 10. So answer is nearest integer. Answer is already integer. So the end of the question, the answer is 10. This is end of the question. So now I'm going to discuss ME stream questions. Hello, hello. Now these are mechanical 2023 gate mathematics questions. I'm going to discuss now. The question is, a machine produces a defective component with a probability of 0.015. The number of defective components in a packed box containing 200 components produced by the machine follows a Poisson distribution. The mean and variance of the distribution are options given. This is from engineering mathematics from the topic probability and statistics, subtopic distributions. Poisson distribution mentioned finally. These are the key points. Asking about mean and variance. In a Poisson distribution, mean is equal to variance, which is equal to lambda, where lambda is the parameter. So here the small p, probability of occurrence of a defective component. Number of defective components is already given 200 components. These are the key points. Now, solution. First, we cannot find directly lambda. Lambda is not given directly. So lambda value n into p. So let small p is equal to probability PR or capital P notation, defective component, probability of getting a defective component is given already 0.015, and n is equal to number of defective components 200. So this is very large, not required to write this data. Very large. P should be very small. 0.015, very small. These are the assumptions generally when we are applying a Poisson distribution to the given problem, but already mentioned in the question, Poisson distribution. So then the parameter lambda is the parameter of the Poisson distribution, which is also called average or mean of the Poisson distribution. So 200 into 0.015, that is 15 by 1000 I can write. Okay, so finally this simplifies to 200 into 15 by 1000 is equal to 3. So this is average. Now, so what is x? X be a random variable, Poisson random variable, denote the number of defective components. Understood or not? So let x be a Poisson random variable, that is Poisson distributed random variable, denote number of defective components. Okay. See, this is given and this is also given, and the relation between n and p, that is lambda is equal to n into p. This is Poisson random variable, Poisson distribution random variable is x, number of defective components. Now, then mean lambda, mean is denoted by expectation of x is equal to lambda, which is nothing but already we calculate 3, and variance of this x, variance of the distribution comma v of x is nothing but lambda. That is also in only Poisson distribution we are having mean is equal to variance, so this is also 3. So mean and variance are equal to 3. Accordingly, the answer is option A. This is end of the question. Now, the question is, the figure shows the plot of a function over the interval minus 4 comma 4 closed interval minus 4 comma 4. Which one of the options given correctly identify the function? So this is the graph given figure. ABCD 4 options given. This is from engineering mathematics from the topic calculus basics, and the solution is, so in some problems using the graph finding the corresponding function takes more time or difficult. In such cases we go by verifying the options. So each function, each function in the options denoted by f of x or y variable. Understood or not? So let y is equal to f of x be the given function. This is the graph. Every function having a curve graph. Given function, fn means function, in over the interval minus 4 comma 4 closed interval. So that means all x values, function defined on x values taking minus 4 to 4 including both. Okay, so y values is obtained by function only. After getting y values, plotting these, pointing these x comma y points in the graph and joining these points by a smooth curve, then only you will be getting the this type of curve. So this curve means y values. From this curve, y values. So whenever the graph or curve lies above x-axis, that y value is positive. So clearly, from the graph, okay, y values lies between, see here, 0, positive I told you. Maximum value of this curve is at 2 only. So this is also at 2, this is also at 2. Okay, so 0 less than or equal to, y less than or equal to 2. Am I correct? We have 0 less than or equal to f of x less than or equal to 2. So this f of x is nothing but y. See, y values along this curve, on this curve, throughout this curve, y values lies between 0 to 2 only at any point. So verify the given options. What is the meaning of verifying the given options? So in each option, we have to denote this is y variable, y value, y is equal to mod 2 minus x. X value is given. Let us take the integer values 0, 2, 4, minus 2, minus 4. Find the corresponding y values. If y values lies between 0 to 2, then the corresponding option is the required answer. If any y value from the option exceeding 0 to 2, that is outside the interval 0 to 2, because y values lies between 0 to 2, then that option is wrong. Okay, so option A. Let y is equal to mod 2 minus x. Now this is your f of x. Y is equal to f of x be the given curve or given function. I told you. We start with that sentence only or not? Now, at first, x is equal to minus 4, x is equal to minus 2. You can start like that or 0 onwards and go to negative values also. At x is equal to minus 2, comma, y is equal to how much? Modulus of 2 plus 2 is equal to 4. So, which is not possible. Which is greater than 2. Okay, not possible. Because y values, function values lies between 0 to 2 only. So, therefore, option A is not correct, is incorrect. You understood or not? Following or not? Now, second option, modulus of 2 minus mod x. Option B, let y is equal to modulus of 2 minus mod x. Okay. Now at x is equal to -4 implies y is equal to mod 2 minus mod minus 4 is plus 4, mod 2 minus 4 is minus 2, mod minus 2 is plus 2. So let us check. When x minus 4, y value 2 or not. X minus 4, this is your corresponding y value. Y value is corresponds to here 2. Okay. At x is equal to -2, corresponding y value, modulus of 2 minus mod minus 2 is plus 2. 2 minus 2 is 0. Okay. Next, at x is equal to 0 implies y is equal to modulus 2 minus 0, mod 0 0, mod 2 value 2. At x is equal to plus 2 implies y is equal to 2 minus mod 2 value 2 is equal to 2 minus 2 0. At x is equal to 4 implies y is equal to modulus of 2 minus mod 4 is 4 is equal to mod minus 2 is plus 2. Okay. So please check. Corresponding y value is 2, 0, 2, 0, 2. 0 to 2. See the graph completely. -4 corresponding y value 2, 0 corresponding y value 2, 4 corresponding value y value 2. At -2 plus 2, the graph meets the x-axis, touches the x-axis. On x-axis, y value 0. So at x is equal to -2 plus 2, y value correspondingly 0 or not. At x is equal to -2, at x is equal to plus 2, corresponding y value 0 or not. We got remaining -4 plus 4 plus 0, I mean 0, we got y value 2. So therefore, option B is correct. You can verify the remaining options at home. Okay. So the answer is accordingly option B. This is end of the question. Or if you know well the concept or geometry, we know the graph of y is equal to minus mod x. This is the graph. Okay. So this is y axis, origin, this is x axis, and this graph is y is equal to minus mod x. So first, to get the graph of the given function, shift this y is equal to minus mod x in upward direction by 2 units. You will be getting y minus 2 is equal to minus mod x, and then taking modulus, okay, you will be getting the required function. When you take modulus y value is positive, that is, you know that below y values, according to image or reflection procedure, you will be getting this. Okay. So actually, 2 minus mod x, shift this graph by 2 units in upward direction. Shift the curve, okay, by upward direction towards 2 units. Okay. Shifting the graph up by 2 units and then taking the modulus of the resultant function. Okay. Then you will be getting the graph of the required function defined over the interval -4 to 4. That is graphical method. This is analytical method, options method. Okay. This graph actually, see, if you understand well, continuously, and this is also like this. Now shift this V-shaped curve, okay, towards up by 2 units. Then take modulus the remaining negative part of y, that is negative values of y. After taking modulus will become positive. Then you know that the meaning of negative values to positive values means by taking image. Okay, am I correct or not? Now the next question. The question is a vector field b of x comma y comma z is equal to xi plus yj minus 2zk. This is vector function b bar is defined over a conical region having height h is equal to 2. This is height. And base radius r is equal to 3. This is radius, or this is also radius. And axis along z axis. This is axis of the cone, z axis, as shown in the figure. The base of the cone lies in the xy plane. That is the circle. Base of the cone is circle lies on xy plane and is centered at the origin. This is origin, center of the circle. This is the dot line, and this thick line shows a circle only. If n cap or n bar denotes the unit outward normal to the curved surfaces of a cone, the value of the integral over s b dot n ds equals. This is from engineering mathematics, from the topic vector calculus, vector integration. We can apply Gauss divergence theorem because function b, that is f bar, is a 3D vector. S is a closed surface enclosing a volume. This is a surface of a cone. So n cap n bar, this is n cap or n bar, is unit outward normal vector also. All these are the points, key points in the statement of Gauss divergence theorem. Okay, so what is the closed surface here? Not only lateral surface, base surface also. That's why they have shaded by violet color. Okay. Solution. Here, yes, is a closed surface of a cone, including base, base of the cone. Okay. So therefore, and b bar is 3D vector, three-dimensional vector. Therefore, by using or by applying the Gauss divergence theorem, comma, integral over v. I mean, the question is integral over s. Okay. Integral over s. Actually, this is a closed surface symbol. In place of f bar, it is b bar. But if the letter to be bold, when the letter to be bold, it is nothing but vector only. N cap given like this. Okay. And b bar given like this. ds is nothing but integral over v div f bar. In place of f bar, we have b bar. Div means divergence. Volume element dv means. Okay. So how do you find divergence? For the given vector function f bar or b bar, dou by dou x of I cap coefficient plus dou by dou y of j cap coefficient plus dou by dou z of k cap coefficient. That is f1, f2, f3. F bar is equal to f1 I bar plus f2 j bar plus f3 k bar. Then div f bar is equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So is equal to integral over v dou by dou x of f1. So what is that f1? I bar coefficient, that is I cap coefficient is x. Dou by dou y of j cap coefficient, that is f2, that is y, plus dou by dou z of k cap coefficient, that is f3, that is minus 2z. All these three terms integrating with respect to or over v. So whenever you will be getting this expression is a constant, apply volume. Integral v dv represents volume. Whenever you will be getting some x, y, z or x plus y plus z term, then this integral over v is nothing but triple integral. After finding x, y, z limits, then integrate term by term. That is integrate one by one successively. So this is integral over v 1, x derivative 1, y derivative with respect by 1, z derivative with respect to z is 1, so minus 2z derivative is minus 2. So you will be getting 0. This is 0. Definite integral 0 means 0. Okay. So the value of the given integral using Gauss-Divergence theorem becomes 0. If you do not identify Gauss-Divergence theorem, it takes more time. Evaluating a surface integral is not easy. Taking the projection of the surface in xy plane, yz plane, zx plane, after that evaluating the given surface integral by converting into double integral. Okay. First of all, how do you evaluate surface integral means? First, you take the projection of the given surface on any one of the coordinate planes x, y, 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 z, z, y, x, as usual. I mean, as you like. Then take the projection of s on that plane. Then that given surface integral converted into double integral over the region or where r is the projection of the given surface. So it is time consuming, lengthy procedure. So that's why they have asked they connect the problems with Gauss-Divergence theorem only. In such a way that using Gauss-Divergence theorem only, they are asking this surface integral. Actually, this is a descriptive question. Okay. So finally, the answer is 0. This is the end of the question. Okay. Numeric question only. Now, the question is a linear transformation maps a point xy in the plane to the point x bar comma y bar to the point x bar comma y bar according to the rule x cap is equal to 3y, y cap is equal to 2x, then the disk x square plus y square less than or equal to 1 gets transformed to a region with an area equal to dash. Round off to two decimal places given. So this is from engineering mathematics from the topic calculus basics, actually related to uh, coordinate geometry also, and uh, what we called mensuration, that is area, volumes. Anyhow, this is 12th standard basics also, that calculus problems. But we are taking into this calculus basics in engineering. The solution is, what is linear transformation given? This is x bar is equal to 3y, y bar is equal to 2x. Now this is gets transformed into a region with an area equal to, that is asking. Okay, just substitute this transformation into this plane. Disk is means closure circle only. Actually, disk is in the shape of circle. Now using this transformation, this circular disk is transformed to some region, is transformed to some curve, and the region bounded by that curve, the area is equal to. For that region bounded by the curve in the new coordinates, we are going to find area. So given transformation, x bar, y bar are the new coordinates, x comma y old coordinates. Substitute this xy here, you will be getting a new equation in x cap y cap coordinates. So that is the new region. So that region definitely bounded by some curve. When you know that name of that curve equation, for that you are going to find area of the region. Okay. Given linear transformation is x cap is equal to 3y, comma y cap is equal to 2x. From this, find x and y values. X is equal to y cap by 2 from this relation, and from this relation I can find y value, x cap by 3, because given region I mean, the given disk containing xy variables. So these equations, I am taking equation 1 and disk equation x square plus y square less than or equal to 1 is the given region. Okay. So this implies substituting the equation 1 here, x bar, I mean x cap x value y cap by, okay, y cap by 2 whole square plus y square x cap by 3 whole square less than or equal to 1 using 1. Now this simplifies to first write x cap square divided by 3 square 9 plus y cap square divided by 4 less than or equal to 1. Looks like x square by a square plus y square by b square is equal to 1. So this is an ellipse curve. Less than or equal to 1 means it is a region bounded by the ellipse. So which is a region of the ellipse or bounded by ellipse with an area. Ellipse x square by a square plus y square by b square is equal to 1 has an area pi ab units. Have you remembered or not? With an area, comma, a, area denoted by generally a is equal to pi ab. Okay. So 3 into 2, where a square is the length of the major axis and 4 is the length of the minor axis. I mean, a is equal to length of semi major axis, small b is equal to length of semi minor axis. So this is 6 pi, approximately equal to 18.84 square units. Okay. Now here I am writing formula. Since area of the ellipse x square by a square plus y square by b square is equal to 1 is pi ab, where small a is the length of the semi major axis, small b is the length of the semi minor axis. A is length of, when major axis equal to minor axis, that ellipse becomes circle. Semi major axis, and the small b is length of semi minor axis. Okay. So the answer is 18.84. This is the end of the question. Now the question is the value of k that makes the complex valued function analytic, where f of z is equal to e power minus kx cos 2y minus I sin 2y. Analytic, where z is equal to x plus iy. So this is a typing mistake. You are not required to write again analytic. That makes the function analytic, where f of z is equal to, where z is equal to x plus iy is dash. This is from engineering mathematics, from the topic complex variables, subtopic analytic function. The solution is, when we know that w is equal to f of z is equal to u plus iv is analytic from necessary and sufficient conditions, The four partial derivatives dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y exist and continuous, and the Cauchy-Riemann equations are satisfied. Okay. Now solution. So f of z is equal to given e power minus kx into cos 2y minus I sin 2y. So comparing this is with u plus iv. Usually f of z is denoted by u plus iv. Okay. Implies u is equal to real part of the function f of z e power minus kx cos 2y, and v is imaginary part of the function f of z, analytic function or whatever it may be, complex function, minus e power minus kx sin 2y. Okay. F of z, the value of k that makes the complex valued function to be analytic. Okay. F of z is analytic implies Cauchy-Riemann equations, CR equations, will be satisfied. Or CR equations satisfy. Okay. That is dou u by dou x is equal to dou v by dou y. Just take one CR equation is sufficient to find k value. Dou u by dou y is equal to minus dou v by dou x. For u, partial derivative with respect to x is cos 2y constant e power minus kx derivative minus k times e power minus kx into cos 2y. This is equal to dou v by dou y. For v, partial derivative with respect to y means exponential is constant, sin 2y derivative 2 cos 2y. So finally minus 2 times e power minus kx sin 2y. Okay. Sin 2y derivative 2 cos 2y. Am I correct or not? Sin derivative plus cos. Both sides exponential, cos 2y cancel, minus cancel. You will be getting directly k is equal to 2. Okay. So the answer is 2. This is end of the question. The question is, which one of the options given is the inverse Laplace transform of 1 upon s cube minus s? U of t denotes the unit step function. 4 options ABCD given. This is from engineering mathematics from the topic Laplace transforms. The solution is, so here this is f bar s. Capital F of s or small f bar s you can denote. Apply inverse Laplace transform. You will be getting the answer in terms of t. See that options. Okay. So let capital F of s this is, or not required to write capital F of s. So how do you evaluate for this function of s inverse? Either standard formula or applying partial fractions after factorizing the denominator. Okay. So this is nothing but s into s plus 1 into s minus 1. Can I write like this? Okay. So how do you find the partial fractions? Is equal to a by s plus All the three factors are linear factors, distinct linear factors, non-repeated linear factors. So corresponding partial fractions is a by s plus b by s plus 1 plus c by s minus 1 using PF, stands for partial fractions. Now taking LCM on the right side and cancel the denominators on both sides, you will be getting 1 is equal to a into s plus 1 into s minus 1 plus b into s into s minus 1 plus c into s plus 1. So put s is equal to 0, minus 1, plus 1 respectively. Successively or respectively. We get first s is equal to 0. Left side there is no s term. 1 is equal to a into 1 into minus 1. The remaining terms 0. You will be getting a is equal to minus 1 directly. Next, putting s is equal to minus 1, you will be getting left side 1, right side a into 0, b minus s is equal to minus 1, b is remained into minus 1 into minus 2. You will be getting b is equal to plus of and 1 is equal to putting s is equal to plus 1, a into 0, b into 0 directly. You will be getting c into 1 into 2. So from this, c is equal to 1 by 2. So a minus 1, b half, c half. Okay. So therefore, L inverse 1 by s cube minus s is equal to minus L inverse of each partial fraction. A value minus 1, take out 1 by s, plus b value half, take out L inverse of 1 by s plus 1, plus c value plus half, take out half times L inverse of 1 by s minus 1. So this is equal to 1 by s inverse Laplace transform is 1 because Laplace of 1 is 1 by s. 1 by s minus a inverse transform is e power at because L of e power at is equal to 1 by s minus a. So half times e power minus t. This is also half times e power plus t. Okay. So all these three terms I can multiply it by u of t because Laplace transform of u of t minus a is e power minus as by s. L of u of t is 1 by s. Okay. Where u of t is unit step function. If u of t is not multiplied in the given options, then your answer is minus 1 plus half into e power minus t plus half into e power t. This is the correct answer actually. But according to the option, we have to proceed. So that means I multiplied all these three terms by u of t. If you take Laplace transform on the right hand side, you will be getting the corresponding answer 1 by s cube minus s. You can verify at home by using second shifting theorem or anything. Where u of t is the unit step function. Okay. So finally, the answer is minus 1 plus half into e power minus t plus half into e power t into u of t. So two options containing u of t. So we are getting these three terms. This is. So the answer is option A. This is the end of the question. Next. The question is the smallest perimeter that a rectangle with area of 4 square units can have is dash. This is from engineering mathematics from the topic calculus basics. And the solution is that calculus also maximum minimum related problem, application oriented problem. Solution. Rectangle having two dimensions length and breadth. So let x comma y be the length and breadth of a rectangle. Here respectively. RESP means respectively. X denotes length, Y denotes breadth, like that. Then the question related to area given 4 square units. They are asking smallest perimeter. Smallest means minimum. So minimum synonyms is smallest, shortest. Maximum synonyms longest, highest, greatest, farthest. So instead of directly maximum minimum, they can ask like this. Then area, comma A 4. This is given. What is area of a rectangle? Length into breadth. That is x into y is equal to 4. It is a two variable function. From this, I can find either x or y. Better to find y value in terms of x. 4 by x. Equation 1. Now the question related to minimum perimeter. So your function is perimeter. Let f is equal to perimeter of rectangle. So perimeter of rectangle is 2x plus 2y. 2 into length plus breadth. So this is 2 into x plus y. Again, it is a two variables function. This is two variables. Convert into one variable function if possible. Yes, it is possible. From 1, I can write y is equal to 4 by x using 1. Okay. Now, this is 2x plus 8 by x. This is one variable. You know the procedure for maximum minimum of a one variable function. So first f dash x. Okay. For f to be smallest, in order to find the minimum function or maximum of a function, comma, we have first derivative equal to 0. F dash x equal to 0. If second derivative greater than 0, then f is minimum, that is f is smallest. If second derivative less than 0, f is greatest, that is maximum. So f dash x, x derivative with respect to x is 1, 1 by x derivative with respect to x is minus 1 by x square. Using x power n differentiation is n into x power n minus 1. So 2 minus 8 by x square is equal to 0. This simplifies to 2 is equal to 8 by x square. This simplifies to x square is equal to 4. This simplifies to x is equal to 2 because x is always positive. Plus v. Why? When you take dimension, dimensions never be negative. Never be negative as well as 0. Always positive. So dimensions never be non-negative. Please remember. Okay. So therefore, and f double dash x you will be getting. You can cross check f double dash x also. Definitely it will be greater than 0. Clearly f double. Okay. So this is one stationary point. Is stationary point according to the procedure of maximum minimum. So clearly, actually not required to verify second derivative. When you get x value, substitute here x value, you will be getting the corresponding function value. The corresponding function value means perimeter value. That is already, they have asked only smallest. So at this one point, definitely this perimeter becomes smallest. If you get two stationary point, two x values, three x values, you have to find second derivative. Otherwise, you can stop here. So clearly, f double dash x greater than 0 at x is equal to 2. Okay. So therefore, f is smallest when x is equal to 2. Okay. Therefore, the smallest in bracket minimum perimeter is f of 2. That is function value at x equal to 2. Or you can find y value, substitute here also. This is equal to 2 into 2 plus 4 by 2. This is one variable. Directly I can write like this. Okay. So 2 into 2 plus 2, 2 plus 4, 8. So 8 units perimeter, smallest perimeter. So the answer is 8. This is the end of the question. The question is, consider the second order linear ordinary differential equation x square d square y by dx square plus x dy by dx minus y is equal to 0, comma x greater than or equal to 1. With the initial conditions, y at x is equal to 1 is 6, dy by dx at x is equal to 1 is 2. The value of y at x is equal to 2 equals. This is from engineering mathematics from the topic differential equation, subtopic higher order linear differential equation. So here it is mentioned second order, highest derivative is 2, linear equation. Dependent variable should not multiply by the derivatives, and dependent variable, all the derivatives should have the power 1. Then only it is called linear equation. And the right side 0 means homogeneous. This is also satisfying the condition. The power of x is equal to the corresponding order of the derivative. In each term, the power of x is same as the order of the derivative. This is also called Cauchy-Euler equation. You know that how to solve Cauchy-Euler equation. Okay. Now this two initial conditions given. They are asking y value at x equal to 2. So this is satisfying Cauchy-Euler equation. This is the key point. See, solution. DE means differential equation. X square d square y by dx square plus x dy by dx minus y is equal to 0. This is equation 1. Okay, comma is a Cauchy-Euler equation. So how to solve? Put z is equal to log x, then theta is equal to d by dz, x into dy by dx is equal to theta y, x square into d square y by dx square is theta into theta minus 1 into y, etc. Okay, so this implies, I can write, put z is equal to log x ln x implies x is equal to e power z. Okay, comma we have x into dy by dx is equal to theta into y, x square into d square y by dx square is equal to theta into theta minus 1 into y, comma theta is equal to derivative with respect to new independent variable z, x is old independent variable. Okay, so these are the key points. Okay, this is Cauchy-Euler equation. Now, so therefore 1m plus, substitute this data in equation 1, theta into theta minus 1 into y. I am not writing here y. I want to put y outside. That is, y is getting common on the right side. In the post position, not right side. So in all the terms of the left hand side, there is a y is getting common. That means I can take out y because this d by dx is an operator operating on y variable. So x into d by dx, that is theta into y. I'm not writing y, and after taking y outside, this will become minus 1 for all these terms operated on y, multiplying by y is equal to 0. So this simplifies to theta square minus 1 into y 0, theta into minus 1 plus theta got cancelled. So this is, say, equation 2 is a linear differential equation dE with constant coefficients. In equation 1, derivative is multiplied by x square term, that is variable coefficient. This is now here x terms are eliminated, variable coefficients become now constant coefficients. Okay, now whenever the right side 0, such equation is called homogeneous and the solution is, general solution is complementary function. So y is equal to cf, that cf depends on auxiliary equation. So how do you write auxiliary equation? Theta square minus 1 is equal to 0, or you can write m square minus 1 is equal to 0, putting theta is equal to m. M is equal to minus 1 comma 1, two distinct real roots, m1 comma m2. Okay, so let us denote m1 comma m2, two distinct real roots. Therefore the general solution, gs means general solution, is y is equal to cf. What is cf? C1 into e power m1x plus c2 into e power m2x, but x is replaced by z variable because we converted the independent variable x into z variable. So c1 into e power minus z plus c2 into e power z. Now convert this z into x variable. So e power z is x. Here e power minus z becomes x power minus 1. So c1 by x plus c2 into x. So let us say this is equation 3. Now one of the condition given dy by dx. So from this c dy by dx implies differentiate both sides with respect to x, you will be getting dy by dx is equal to c1 by x. 1 by x derivative is minus 1 by x square. So minus c1 by x square plus c2 into x derivative 1. Let us say this is equation 2. So using, what are the conditions given? Y of 1 is equal to 6. Y is equal to 6 when x is equal to 1. And dy by dx is equal to 2 when x is equal to 1. Say these are given or not? Dy by dx of 1. This is dy by dx at x equal to 1, y at x equal to 1. Comma, substituting these in equations 1 and 2. So finally 1 and 2 gives, in equation 1 we have y is equal to c1 by x plus c2x. So y value 6, x value 1. So c1 plus c2. Let us say this is 4. I mean already uh, this is equation 3 and this is equation 4. So 3 and 4 gives actually. This is fourth equation. This is equation 4. Now substituting these conditions in 3 and 4. You can check 3 and 4. One is the given equation. Constant quotient is equation 2. Y value equation 3 solution. And dy by dx value is fourth equation. So 3 and 4 gives. Now this is 5. Or not required to. Right. And in this also dy by dx value 2. X value 1 minus c1 plus c2. 6. So solving 5 and 6, adding 5 and 6 or subtracting 5 and 6, you will be getting 1 by 1 c1 c2 constants. We get c1 is equal to 2 and c2 is equal to 4. 4 plus 2 6. 4 minus 2 is equal to 2. Satisfying the conditions or not? Substitute these conditions, these c1 c2 values in the solution 3. So therefore 3 is equal to, 3 implies, or y is equal to c1 by x, 2 by x, c2x plus 4x. Now they're asking the y value at x equal to 2. At x is equal to 2 implies y is equal to 2 by 2 plus 4 into 2. Okay, so this is 9. Therefore, the value of y at x is equal to 2 is, this is the answer. This is the end of the question. The question is, the initial value problem is solved numerically using the forward Euler's method with a constant and positive time step of delta t. Let yn represent the numerical solution after n steps, obtained after n steps. The condition mod yn plus 1 less than or equal to mod yn is satisfied if and only if delta t does not exceed. This is from engineering mathematics, from the topic numerical methods, subtopic numerical solution to ordinary differential equation. The solution is, see, what are the key points here? Forward Euler's method, first of all mentioned. H value, delta t given. Yn is the solution obtained after n steps, n iterations. This is the condition. Using this condition, delta t, H value does not exceed. We are going to find. So, this is also called stability analysis in Euler's method. Okay. So, to reduce the error, whenever we are finding step-by-step solution y1, y2, first approximate solution, second approximate solution, comparing these solutions with exact solutions, if your error is reduced by step-by-step solution compared to exact solution, then the method is called stable. Otherwise, the method is called unstable. So for that maintaining stability analysis, there is some condition formula is there. Okay. So first, what is that formula? Mod e less than or equal to 1. Once we write the forward Euler's method, yi plus 1 is equal to yi plus h times f of xi comma yi converted to yi plus 1 is equal to e into yi plus hk. So using that method. Okay. So anyhow, that condition is given. So differential equation is already standard form or not? So here actually the initial value problem here missing. I am writing dy by dx plus 2y is equal to 0 with y of 0 is equal to 1. This is missing in this problem. Kindly excuse me. Please add this. Okay. So differential equation implies, can be written as, to apply these numerical solutions, Euler's methods, etc., express the given equation in standard form, that is dy by dx is equal to function of x and y variables. So this is shift this 2y to right side, you will be getting minus 2y. Okay. So from this is your function of x comma y. So this is your f of x comma y. Okay. Now y of 0 is equal to 1 means not required to write. Let h is equal to delta t with a time step. Usually time step denoted by h, iteration step. Okay. Next, the forward Euler's method or iteration formula is yi plus 1, or you can write yn plus 1 also, is equal to yn plus h times f of xn comma yn. Okay. So this is equal to yn plus h value, we don't know, function of x comma y, that is minus 2, y is replaced by yn. This is f of x comma y. We want f of x n comma yn. So in this, y is replaced by yn. Take yn common. 1 minus 2h into yn. So condition is, given condition is mod yn plus 1 less than or equal to mod yn. Using this condition, we have to find that h value does not exceed. The value of h does not exceed is the required. Okay. So this implies and implied by mod yn plus 1 already we got. Okay. So let us say this is equation 1. Modulus of 1 minus 2h into yn less than or equal to mod yn. Right hand side, this is right, this is left, no right is no change, using 1. Understand or not? Now mod ab is mod a into mod b. So this implies mod 1 minus 2h into mod yn less than or equal to mod yn. On both sides, modulus is always positive. So we can cancel on both sides of inequality the positive quantity. Inequality will not be reverted, will not be changed. So this implies mod 1 minus 2h less than or equal to 1. So this implies, it looks like mod x less than or equal to a minus 1 less than or equal to 1 minus 2h less than or equal to 1. Okay, using that modulus inequalities. Okay, since comma mod x less than l implies and implied by minus l less than x less than l. This is the inequality I have used. So now we want to find h, eliminate this plus 1 and minus 2. To eliminate this plus 1, add for all the three terms minus 1. Minus 1, minus 1 less than or equal to minus 2h less than or equal to 1 minus 1. Okay. So this simplifies to minus 2 less than or equal to minus 2h less than or equal to 0. Now multiplied by or dividing by minus 2. You will be getting minus 2 by 2 greater than or equal to, when you are multiplying or dividing by a negative quantity for an inequality, the inequality symbol will be reverted. So minus 2h by minus 2 greater than or equal to 0 by minus 2. This simplifies to minus 2. We have to divide 1 greater than or equal to h greater than or equal to 0. This same can be written as implies and implied by 0 less than or equal to h less than or equal to 1. So this is your delta t. So the time step is bounded between 0 to 1, is between 0 to 1 only. It never exceeds 1. Okay. So therefore h is equal to delta t does not, they're asking does not exceed that value. How much? 1 only. This is the answer 1. Okay. So the answer is 1. This is the end of the question. Okay. Now I am closing the session. We will meet in the next class.